Pearson correlation coefficient is a measure of the linear correlation between two different variables and is the primary measure of correlation in elementary statistics. The Pearson correlation coefficient is symbolized by an R, and it can only have values between -1 and 1. To look at what these values actually represent, we're going to look at a series of scatter plots. So to make our scatter plots, we go ahead and put our explanatory variable on the x-axis or the horizontal axis, and our response variable on the y or vertical axis. Now if the R value is 0, that means there's no linear relationship between our variables, and we would have the following data set for an example. Now with no relationship between the two variables, we can't predict what's going to happen if we change the explanatory variable. For example, if we to increase the explanatory variable, we could increase the response variable or decrease the response variable. All those would be valid options with an R value of 0. And likewise, if we decrease the explanatory variable, we could increase the response variable or decrease the response variable. We can't tell with an R value of 0. Now an R value of less than 0 means we have a negative correlation. In a negative correlation, the data points would look like this on our scatter plot. It's called a negative correlation because of the downward trend that the data points are traveling in. So as we increase the explanatory variable, we would expect that the response variable would decrease, and as we decrease the explanatory variable, we would expect the response variable to increase. Now as the points come closer to an actual line, we say that the correlation increases, or we have a stronger correlation. This would result in our R value approaching -1. So the closer the R value is to -1, the stronger the negative correlation is. If, on the other hand, we had an R value of greater than 0, then we would have what's known as a positive correlation. With a positive correlation, the scatter plot would look like this. Unlike a negative correlation, a positive correlation, there's an upward trend to the data, which means that as we increase the explanatory variable, we would expect the response variable to also increase. And likewise, as we decrease the explanatory variable, we expect the response variable to decrease as well. And just like the negative correlation, as the dots get closer and closer to an actual line, we say it has a stronger and stronger correlation. And that, in this case, our R value would actually get closer and closer to 1, indicating that we have a strong positive correlation.